Good morning. Let us start with the second lecture for the thermodynamics. Let us start with state function. State function. State function means it is the current situation of the system. It does not mean with the liquid, solid or gaseous state of the system. This is the current situation of the system. State means the current situation of the system. So if you take certain amount of gas in a container, and this is the amount of gas, and you apply some pressure with the help of the piston. Suppose P is equal to 1 bar, that is the pressure applied on this system. V is the volume, suppose 1 dm cube is the volume here, and if you apply some temperature, at temperature 300 Kelvin suppose, so this initial state of the system can be P1, V1 and temperature is T1. So P1 is equal to 1 bar, suppose volume is 1 dm cube, that is initial volume, and temperature is 300 Kelvin. So this is the initial state of the system. So these values, that is 1 bar, 1 dm cube and 300 Kelvin, these are the values which specifies the initial state of this system. This initial state of the system can be changed to final state of the system by changing the pressure here, and accordingly the volume will also change. So you can write here in the simple way, that is P1 is the initial pressure, V1 is the initial volume, and temperature, that is T1. It can be changed from P1 to P2, V1 can be changed from V1 to V2. Temperature will have to keep constant, and number of moles, you can add one more thing here, number of moles also can be unchanged, that is N. So P1 and V1, P2 and V2, or in short pressure and volume, the values of these two variables, it depends on the state of the system. So these are called as the state functions. State functions. If you change the temperature from T1 to T2, means if you take another example where there you can change temperature, in this particular case we have kept this temperature constant, because if we change the temperature, so the situation will again be a different one, so we'll have to keep this temperature constant for this one. So if you change temperature for T1 from T1 to T2, this again temperature can be a state function. So pressure and volume here in this particular example, they can be called as a state function because their values depends on the current situation, initial and the final situation of the system. So these are called as the state function. Now if this same concept can be explained by using a very simple example, if I got a cup of tea, initially if it is in hot condition near about approximately 50 degrees Celsius, after some time if it cools down, suppose up to 25 degrees Celsius, so this is the first step or initial state of this. This can be a final state of this. So initial and final state, initially the temperature was 50, final the temperature was 25 degrees Celsius. So here it is in hot condition or hot state, here is a comparatively cooler state or cold state. So the state of the system can be changed from hot to cool one. Now here it means that there is change in temperature. If you want to change the state of the system, you need to change some properties of the system. In earlier one what we did, we just changed the pressure from P1 to P2 and volume from V1 to V2. In this particular very simple example, there is change in the temperature from 50 degrees Celsius to 25 degrees Celsius. Means that if you want to change the state of the system, you have to change some properties like pressure, volume and temperature. So these can be called as a state function. Pressure, volume, as I already told, pressure, volume and temperature, these are called as the state function. Now the next is the path function. This is path function. Path function means what? Path function, it depends on the path through which the reaction is carried out. It depends on the path of the reaction to be carried out here. So if you take, suppose you are standing here and you want to climb up to this hill at this height. Initially, potential energy here at this particular point, it is mgh. As you all know, potential energy is equal to mgh. At this point, potential energy will be again mgh, and this h will have some value. Suppose for our convenience we write 200 meter, means we want to climb the hill up to 200 meters. So you can, one way you can just directly go through this way and reach over here. This is the first path, or this much height you have to cover, or secondly what you can do, you just go by zigzag way, going this way, and you can reach up to this point. This is the second path, but ultimately you are reaching this point. Whether you follow path number 1 or whether you follow path number 2, you are reaching at this point, and the values for potential energy in both the cases would be the same, whether you follow path 1 or whether you follow path 2. So potential energy will remain same. This potential energy will remain same if you follow either paths, or path 1 or path 2. So here potential energy at this particular point, it will be 0 because height is 0 here, suppose. Then in second path, if you concentrate on this second path, though potential energy is same compared with the first path, but the work done to reach up to this height would be different, because if you follow the second path, more work is done here. So work done is different. Potential energy is same by both the paths, but work done is different if you follow path number 1 and if you follow path number 2. In second path, what happened? Work done, it's called as the path function because it depends on the path of the reaction. It depends on the path of the reaction. So it's very obvious that if you follow this path, you will have to do more amount of work compared to if you follow the path number 1. So in both the cases, work done would be different. You might get exhausted while going this way, or some of you might feel that if you go this zigzag way, you might not be so tired, but if you in a one stage, if you want to reach up to this point, you might get exhausted. So it depends on the potential and energy of the person also. So the ultimately work done is different if you follow path 1, and work done will be different if you follow path 2. It means that work done is a path function. Work done is a path function because it differs in if you follow path number 1 and path number 2, but potential energy will remain same in either paths, in both the paths. So potential energy is a state function. Same concept can be very easily understood by the mechanism like SN1 and SN2. I hope up till now, if you are aware about the halogen derivatives, there is a SN1 mechanism, that is nucleophilic substitution unimolecular. We need not go into much detail of this reaction from the organic point of view. I'll just explain the two paths followed by the reaction. This is tertiary halide. It is attacked by another nucleophile, a comparatively stronger one. You will get this product. You are expected to get this thing, and bromide ion is here. It is leaving group. Now if you follow by the SN1 mechanism, what will happen? This CH3 Br, it is a two-step reaction. This OH is attacked on this bromine, and there is a formation of carbocation here with release of bromide ion. Now in second step, this is the first step here. This is first step. In second step, what happens? This carbocation which is formed here, so this carbocation which is formed here, it is attacked by this OH minus, and this is step 2 here, and you will get the final product. Okay, so this is SN1 reaction mechanism. This is first step and this is second step. So this reaction is carried out in 2 steps by this SN1 mechanism. Now if you follow SN2 mechanism, here is very simple. Here it is primary halide. In SN1 it was tertiary halide. Here this OH minus is attacked on bromine, and you are getting here a transition state. Means here change in the energy is same irrespective of the fourth path followed by. Here what is happening? Carbon bromide bond undergoes cleavage here, and at the same time you are getting here the transition state. This is a transition state you are getting, and this transition state, once it is reached, the final product would be, actually here it is OH and this is hydrogen plus bromide ion is escape here. So this is according to the SN2 mechanism. This is one step reaction. Only there is a formation of a transition state here. Now if you compare both the reaction SN1 and SN2, this is SN1, this is first step, this is second step. In SN2 the reaction is carried out in one step only. So whether the reaction is carried out in one step or whether it is carried out in 2 steps, you are ultimately getting this product here, OH. That is, OH is attached to this whatever is the entity here. But the main difference here, if you write the, proceed further, if you draw the graphs or energy diagram for both the reactions, here this is for SN1 and this is for SN2. This is reaction coordinate on x-axis, and here there is a energy, potential energy of course, and this is reaction coordinate. If you draw the energy profile diagram for this SN1, you will be getting here 2 steps. This is the energy of the product, this is the energy of the reactant. Suppose initially energy of this reactant is 10 kilocalories, and after the reaction is complete it is 8 kilocalories. There is a fall in energy. If you go draw the energy profile diagram for SN2, you will get such type of curve. This is one step reaction. This indicates that this is one step reaction. Again, if this is 10 kilocalories is the energy for this reactant, and this is 8, change from 8 to 10 to 8, that is 8 kilocalories. This is the energy for product. So whether you follow SN1 reaction or whether you follow SN2 reaction, in both the cases you are getting 8 kilocalories is the same energy change, that is energy change is 2 kilocalories in both the cases, whether you follow the path SN1 or SN2. So you can conclude here that energy is state function. It is not a path function. It is not path function. This is a very simple example. Now when you say about this is about energy. Now if you come to the concept of heat, it is a path function. It is not a state function, but it is a path function. If you want to change from A to B, there is change from A to B. It may follow path number 1, it may follow path number 2. Now from changing A to B in adiabatic process, Q is adiabatic process. You have not come across this concept adiabatic. I will explain this afterwards, but for the instance adiabatic process, it happens, it is insulated one. There is no energy changes with the system, from the system to the surrounding. And at isothermal there can be energy changes, but temperature is kept constant. Temperature is kept constant by using thermostat. Yeah. So there is, when this, if you follow the change from A to B, Q equal to 0 and Q it is may not be equal to 0. These are the two conditions, Q equal to 0 and Q is not equal to 0. Means if you follow the path 1, Q will be equal to 0. If you follow path 2, Q will be not equal to 0. What is this Q? This is the heat changes or heat simply. Q can be a heat. Means in adiabatic process, as I told, this is the insulated process or insulated mechanism is there. Insulated process means there is no exchange between the system and the surrounding. So its internal energy is used for the completion of the reaction or to bring about the change from A to B. So its own energy is utilized here. So there will be no heat changes. Q will be equal to 0. But in case of isothermal process, as I already told, there can be a exchange of heat or change in the energies from system to the surrounding in case of isothermal process. So in such cases, Q will not be equal to 0. It may be less than 0, it may be greater than 0. Temperature can be maintained by using thermostat. So if you follow the adiabatic path, here Q will be equal to 0. If you follow isothermal path, Q will not be equal to 0. So heat, the value of heat, it depends on the path you follow. That is why heat can be called as a path function. So state function and the fast path function, that is the state function is one whose values is dependent on the state of the system, current state of the system or current situation of the system, and path functions are those which values are dependent on the path followed by the change to bring about the change, that is called as the path function. So this is about, in the next lecture we'll start with the types of processes. Thank you.